Hello everyone, welcome back. Before the break, I had started to revise some measurement concepts, and I also defined the volume and the surface area of a hemisphere. Now, in this portion of the lesson, we're going to be looking at some examples. Let's go to the board. Cool, so the first question says that the diagram shows a cone with a perpendicular height of h centimeters, a radius of r centimeters, and a slant height of 13 centimeters. Here we can see that we have two missing variables. I don't know what my h is, and I do not know what my r is. Okay, so A is asking me to show that the volume of the cone is given by V is equal to 169 pi h minus pi h cubed over 3. Then B is asking me if h is 12 centimeters, determine the total surface area of the cone. So we're going to start with A. And we can see that we have to express the volume in terms of pi and h, because those are what are present, and we know that our end goal is to have volume expressed as this. But if I look at my volume formula for a cone, we can see that it is pi r squared h. So in our end goal, we can see that there aren't any r's included. So that means I'm going to have to find another way to express r. So looking at my diagram, we can see that I have a right angled triangle. And the second that I have a right angled triangle, we need to be thinking how Pythagoras could be helping me. So if I want to express r in terms of h and 13, I could do that using Pythagoras. So r squared will be equal to 13 squared minus my h squared because of Pythagoras. And because I want r by itself, we know that r will be equal to the square root of 169 minus h squared. So that will be r. So now all that I'm going to do in this case is I'm going to replace my expression for r into the volume formula. So I'm going to write it over here. So the volume will be equal to 1/3 pi times my radius, which I've written as the square root of 169 minus h squared. This will be squared and multiplied by h. So the volume will be 1/3 pi. Now just a reminder, when I square something that is under a square root, it just returns to becoming its original form. So this will just be 169 minus h squared, and this is being multiplied by h. In my next step, I'm just going to bring my h to the front, because then I will be able to distribute 1/3 h pi, or 1/3 pi h rather, into my bracket. Because if I do distribute it, I'm going to be left with 169 pi h over 3 minus pi h cubed over 3. And I can see I have arrived at my end goal. So essentially all that I needed to do is express r in terms of h, and that helped me find the volume. Great everyone, I hope that you're with me so far. Just for any of these questions where to show that, please let the answer or the end goal or what you're supposed to end up with guide you, as this can help you with your steps in the problems. Let's do B together. So we now need to determine the total surface area of the cone. The surface area of the cone can be found by saying pi r times the length of the cone plus pi r squared. So please note that this length is referring to my slant height, which I do have. But please will you note that it's now being given that the perpendicular height of the cone is 12 centimeters. So this is particularly helpful because now with this being 12 centimeters, I can actually do Pythagoras to work out what my r is, as I do need my r to fill into my surface area formula. So let's calculate r. We know that r squared will be equal to 13 squared minus 12 squared because of Pythag. Cool. Which means that r squared will be equal to 169 minus 144. So r squared is equal to 25, and if I square root that, I can see that my radius is 5 centimeters. So I can now substitute into my surface area formula. It's going to be pi times 5 times my slant height, which is 13, plus pi times r squared, which will be 5 squared. Now we can plug this all into my calculator to determine the surface area. So it's going to be pi times 5 times 13 plus pi times 5 squared, which I know is 25. So the surface area is going to be 282,74. And I know that my answer will be in terms of centimeters squared, as it is a surface area. Great, everyone. I hope that you're still with me. We're now going to take a look at another example. So, the diagram shows a pyramid with a square base and vertex A. The side length of the base is 16 centimeters. P lies on the square base directly below A. So we can see on our diagram that we've got a right angle and P is directly below A. The volume of the pyramid is given to be 640 centimeters cubed. So now that we have our introductory information, we've got our square base pyramid, and now I'm going to see what questions they actually want to ask me about it. So let's go to the next slide. We're first going to show that the perpendicular height of the pyramid AP is 7,5 centimeters. Then we're going to determine the total surface area of the pyramid. So let's go to A. Cool. So we need to determine that the perpendicular height is 7,5 centimeters. So that means I'm trying to find out this portion of the formula. The volume of a pyramid is equal to 1/3 times the area of the base multiplied by the perpendicular height. So I want AP, which is my perpendicular height. But luckily in this case, I was actually told what my volume is. I know that my volume is 640 centimeters cubed. This will be equal to 1/3 times the area of my base multiplied by my perpendicular height, which is my missing piece of information. But what is the area of my base? I can see that it is a square-based pyramid, which means that all of these lengths are 16 centimeters. But because I know that information, that means that the area of the base will just be length times breadth, which is 16 times 16, because it is a square base. So at this point, all that I need to do is isolate my height. So I'm going to get my calculator out. And if I want to isolate my height, I'm going to have to say 640 divided by 1/3 times 16 times 16. So I'm first going to say 1/3. Sorry, this fraction button is not my friend today, guys. Don't worry. There we go. Now it's working for us. So 1/3 times 16 times 16, which is going to give me 85,3 recurring, but I know I have to divide 640 by that in order to get my height. So I'm going to say 640 divided by my previous answer gives me 7,5. So 7,5 is my perpendicular height, which was the goal that I had at the beginning. Great, so now that we know what our perpendicular height is, I could go on to the second part of the question, which is B. Let's go to B. So we know that the side lengths of the square base are 16 centimeters each. We've now proven that the perpendicular height is 7,5 centimeters. So this height is 7,5 centimeters. Now we want to determine the total surface area of this pyramid. Cool. So what we're going to do is we're first going to find the area of the base, and then we're going to add it to the particular triangles that make up the exterior of this pyramid. But before I do that, I'm actually just going to remind you guys that when I'm working with surface area, the height is referring to my slant height. So I need this particular height in order to calculate the surface area of the pyramid. So I know that my perpendicular height is 7,5, but I'm going to need my slant height for the surface area. So I'm going to have to use Pythagoras in order to find my slant height. So because we know that P goes directly from A down to the middle of this square, PT will be equal to 8 centimeters. So when I'm working out my slant height, I'm going to use Pythagoras. So I know that my slant height will be equal to, my slant height squared will be equal to 8 squared plus 7,5 squared. So I'm going to put this in my calculator. So we've got 8 squared plus 7,5 squared. But I know that I'm going to have to square root my answer in order to establish what my slant height is. So I'm going to square root my previous answer, and I'm going to get that my slant height is 10,97. So now I can actually plug everything into my surface area formula, because I'm going to have the area of my base, which is 16 times 16, plus 2 times the triangles that connect to the base. So it's going to be a half times my base, which is 16, times my slant height, which is 10,97. And then I'm going to add this again. I'm going to just come under here, guys, because I'm going to run out of space, plus 2 times a half times my length, which is 16, again multiplied by my slant height. So now I need to plug this all into my calculator, because that will give me my answer for surface area. So it's going to be 16 times 16 plus 2 times a half multiplied by 16 multiplied by 10,97 plus 2 times a half multiplied by 16 multiplied by 10,97. And guys, if you're wondering what these plus 2 half times 16 times 10,97, all that I'm doing is I'm adding the triangles that make up the exterior of the surface area together in order to establish the surface area. Because for the surface area, I need the area of the base, and then I add that to the area of the 4 triangles that make up the rest of this pyramid. So the surface area will be 607,04. So guys, the surface area of this particular pyramid is 607,04 centimeters squared.